Hello, my name's Chris Gross, and I'm a program manager on the Excel team. I'm super excited to be here today. I also have the benefit of being joined by my colleague Michelle, who's going to get things kicked off. So without further ado, over to you, Michelle.
I'm Michelle Keslin, one of the program managers on Excel, and I'm really excited to be here to talk to you about LET and Lambda today. Today we'll be talking about LET and Lambda, and we want everyone to come away from this talk with a sense of what these functions do, where they could use them, when they should use them, and of course, how to use these. So to do that, we're going to start by talking about some of the benefits that come with abstraction. Then we're going to walk through each of the functions in detail and what each part of them does. And then we're going to hop into some demos and workbooks that will let you see these in real time. Let's start by talking about logic abstraction a bit. An ambitious spreadsheet will have thousands of formulas all over it, and that gets super complex. And it effectively makes the spreadsheet a functional program that can do all sorts of things. But right now, spreadsheets don't really have much in the way of modularity. It's hard to take a small chunk of a spreadsheet and treat it like it's some sort of reusable nugget. So the reason for that is that up until now, the formula language has been missing something that a lot of standard programming languages have, and that's abstraction. So abstraction can happen on values, and it can happen on formulas. And we're going to break that down a bit because the way that you would think about values and formulas has some different implications for how you might do things in your workbooks. So when you think about logic abstraction, the first piece here are values. So those are little things that you have calculated out inside of, say, a function. Little chunks that turn out to actually be a specific value. And when you're thinking about something that's a value, you're going to want to think about the let function. It basically lets you say, hey, I think that this stuff represents, say, the profitability or whatever it is. It's the outcome that you might have from a calculation. And then we have formulas. That's all the sort of logic, the part where you're thinking through and putting values together to form some sort of process for thinking things through. And so that's where Lambda comes in. So Lambda is what you want to use for formulas, and let is what you're going to want to use for a specific value in your formula.
All right, so first up today is to talk about the let function. Now, obviously, this is something that's not totally new and has been in production for a while now, but I also think it's a good primer for those who might not be aware of it or need reminded of some of the benefits before we dive into the deeper topics of Lambda. So kind of as Michelle mentioned, the important thing to think about the let function is that it allows you to put names in formulas, and I'll talk through a little bit of those benefits in a second. So the first thing to take note of is this fact that there's pairs going on here. And what I mean by that is you can see we've got this field or this parameter that's called name. And what you're going to want to put there is just the name of what you want to abstract on. And then the second thing that comes after that is the name value, which is that value that you want to abstract on. So if you look down below, there's a few examples, but I'll walk through those as well. Now, the final thing you need to be made aware of is that there's actually a calculation that can be done at the end of all of this. And that's the place where you're going to want to make use of those names. So putting this all together, in the first case, we've actually named our first name 1. I've just chosen the name 1 because it's really easy to understand. You're probably assuming it's the value 1, which in fact it is. So if you look at that second parameter that we have, or argument, it's going to say the value 1. And what that means is then when I reference that in my calculation, Excel is going to do abstraction under the hood, and you're going to get all the benefits of substitution and abstraction when you write more complex formulas. So the final output of this formula is going to be something pretty simple. We're just going to take that name 1, add that to 1, and we can all do something as simple as 1 plus 1 in our head, and that'll give us the answer 2. Now the other thing to highlight is that it's not just one single name that you can abstract on. One of the major changes we made when rolling this out was adding support for multiple names within the exact same function call. So in the second case, we've actually added the value 2, which again, for ease of purpose of illustration, we've decided to abstract 2 to be the value 2, and then we just add 1 plus 2. And as we all know, 1 plus 2 equals 3, and if you were to take this formula and put it into Excel, you would get the output 3. The next thing to really cover, though, is why use it? What are the major benefits? I just took something that might have actually been simpler to write just as 1 plus 2. You didn't even have to use a function call, and I made it more complicated. Now, there's a few reasons why you might, and you don't always need to use this function. It's not something that you should be using all the time. There's going to be specific cases where you do want to use it and where you don't. So the first major benefit that we like to talk about is just readability. So if you're writing a more complex formula that's got a whole bunch of cell references and other things that it's pointing at, sometimes it can be hard to parse what's going on. Now, you might understand it in the moment and you can totally explain it to your colleague, but maybe you come back to your spreadsheet a month later and you're like, what was this formula doing? And you need to tweak it. LET can actually help those sort of situations become a little bit easier to grok because it makes things more readable. So this above one, as I've been talking, I'm sure some of you might have been looking at the example. You might be wondering just what the heck this formula call is doing. And it's actually pretty simple to logically explain. All it's doing is it's filtering out the weekends. We just want a formula that gets rid of the weekends and then does some logic on that. So if you actually take that same formula and you apply a LET to it, you can do a few intermediate steps. So the first is you might be able to say dates because you're actually pulling the dates from a specific sequence function that's generating all these values. Then the second thing you're going to want to do is apply a filter function, which again logically makes sense. If I just say, hey, I'm going to generate some dates, call this thing dates, and then I want to filter out the weekend, well, that's pretty easy. And that's really what this formula does at the end of the day, but you might be seeing some of the benefits of readability looking at the LET abstraction. The other bit is performance. This one can definitely go unnoticed until you start to do large operations and you're doing them multiple times. So in this following example, I have an if, and this if is just checking some parameter to see if the summation is too big. And if it is, it just returns the value too big, otherwise it'll just sum it up. Now, if you were to take that exact same formula and you were to abstract it with a LET, you'll notice that there's a repeated call, and that repeated call is the sum of A through A. So what Excel is going to do without the LET is it's going to do that huge summation, which maybe is a large value, takes maybe a little bit of time. Maybe you're doing it across an entire sheet and it takes even more time. But then after it checks that it met the parameters, it's then going to do that exact same calculation again. It'll throw away what it knew and then do the exact same calculation. This is another area where LET can actually be beneficial. You can see that repeated expression that we had before, we can just call total. And by calling it total, Excel is able to cache that away and then just return the value when it meets the parameters. The last thing to mention is debugging. Debugging is important with LET because it kind of lets you poke away at the formulas and split things up into logical chunks. Again, these are things that are tantamount when you are used to other programming languages. Most great code and algorithms isn't written with just one giant block of code. It's actually chunked up into small logical sections, and that way it's a little bit easier to debug too, so you just don't have this giant mess of code everywhere. And the same thing can apply with LET. So in this formula that we have in front of us, this actually does a sum of square roots. And there's two operations here. They're rather simple. The first one is it just takes the square root of some set of inputs, A1 through A4, and then it does the sum of those square roots. It sums them up, and then you get your answer. Now, the interesting thing is that in this example I'm showing right here, there's actually an error. And what you're going to see is it gets a pound value at the end of all this. Once you've taken the time to actually write a formula using LET, you can actually just swap those names out and you can figure out where things are going wrong. Clearly, somewhere along this chain, something's happened, and it can't be at the sum of square root level because that's just returning pound value, which ultimately isn't too useful. But if you actually return square roots, what you'll notice is that we're actually getting 4 values, but one of them is returning the pound value, which is ultimately making the formula just return a single value of pound value. Now, I'm not going to tell you what is exactly causing this pound value right now because we have a demo a little bit later where we're going to show a little bit of this live and show exactly what's going on. So hold on to this thought for now, but the important thing to take away is that debugging can be aided through the use of the LET function. The last thing I have to talk about today is an example. Some of you might have seen this one before, but I think it's a good one that illustrates, again, just putting everything together with LET, how you can make use of it. So in this scenario, we have some sales data, and we're trying to go through an entire range. So this range right here is A2 through D8. Now what we want to do is we want to apply a filter. And essentially what we want to do is get information for sales where we had the individual Fred. So we're trying to look at Fred's sales, see how things were going. Now that's pretty easy with the filter function. If you've been paying attention to the slide though, we're getting the 0. And of course, we're all Excel wizards. We can make this better. We're going to go in and we're going to replicate this and remove that 0 and just add a dash in there. And so at this point is where you actually end up getting some of that duplicate logic if you look at the formula that we've authored below. So we've done the is blank thing and we're doing the filtering, but now we actually have to do filter twice to check if that blank's there. So again, just putting that all together, you can see the section in red where it says, hey, here's the filter bit, this is the repeated expression, and we've got these repeated things here. So what we can actually do is using a LET, make this a little bit easier to 1, read, 2, we can get the performance, and then 3, when we come back in the future and we decide that maybe we don't want to filter to Fred or we want to filter to some other parameter, it's actually easier to swap out our formula. We can change that static Fred and point it to a cell or just write something else in there. And so, yeah, if you just look at the final formula that we've been able to create here, you'll notice that it kind of reads in logical order too, which is another benefit that I find when I author these formula this way. So the first is we have our filter criteria, which is just Fred, not anything terribly complicated. The next bit is the filtered range, which is what we want to actually filter. And we actually want to filter that range to the filter criteria. A little bit more easily readable if, for example, you were pointing at a cell reference and you didn't just have Fred there. And then the final thing is pretty simple logic. We're just doing an if check to say, hey, is there a blank cell in that filtered range? If there is, replace it with the dash. Otherwise, just return the value from the filtered range. So I would argue at the end you get a faster, more readable formula, and hopefully this illustrates some of the benefits of LET.
Let's talk about lambdas now and how you can use them to author your own custom functions in your workbooks. So Lambda is going to give you a few key capabilities that may have been more difficult before. The first is all about reuse, right? You can take something awesome that you or someone else has made and you can use it again and again and again. And you don't even necessarily have to remember how it worked. You just say, hey, this calculates this month's revenue and I can just use it with any month I put into it. And it doesn't have to be complicated, right? They're usually pretty simple logics. And anytime you find yourself reusing a formula or a piece of calculation, it means you could benefit from encoding it as a lambda so you can have one place to manage it, which of course brings me to managing your formulas, right? So that's one of the key benefits is that when you take a formula and you duplicate it all over the place through, say, autofill or copy paste, now when you realize that there's an error in it or there's something you want to update, you have to go find every place you've used it and change it. If you make it as a lambda, what you'll be able to do is you'll just edit it in one place and everywhere that's calling it will automatically update for you. That's going to save you a ton of time and you won't have to go through cell by cell tracking down each of those formulas. And then the other key benefit is that it will enable you to do things that were previously impossible. So before, there was a lot you could do with Excel. Like it has been able to do so much for so long, but it wasn't Turing complete. Well, now that it's Turing complete, it essentially means that it can do literally everything that you might want to do through a standard formula language. This is going to enable you to do things like recursion, all sorts of other fun stuff that I'm sure any other CS majors here would be happy to geek out on. So let's look at the function signature of lambda and see if we can break down what it's doing. So here you see, equals lambda. That's just the function name. And then there are two key types of things that we put into it. First are the input parameters. Those are basically the variables that you might want your resulting function to take. And the second is the calculation. This is what it's actually doing, how it's putting those input parameters to use. And so I think it's much clearer if you just have an example. So here we have a lambda on the bottom that is pretty simple. It'll take in two variables, x and y, and it adds them together. Of course, you could do this with the sum function today, but this is just meant to illustrate how you could use a lambda. And so if you wanted to then put that lambda to work, you would give it a name, say my lambda in this case, and then you pass it two parameters. So if we pass 2 and 3 into this lambda, well, it's going to take them, it's going to add them together, and it's going to give us 5. And you can do this with basically any sort of logic that you have. So say you have a recurring need to calculate, how many weeks it's been between two dates. You could make that a lambda. You can count weeks and then just put in 2 dates. Anything you want to do, you could do with a lambda. Now, of course, if you want to actually use lambdas, you do have to give them a name. The name manager is our go-to place for naming things in Excel. So you head on over to the formula tab of the ribbon, you pop up in the name manager, and in there you can define a new name that is basically whatever that lambda was that you were just defining. So we create a new entry, you can give it a name, and you can describe it in any way you want. So that if you go to use it later, or if somebody else comes into your workbook and is using it, they'll know what it does. And then you just pop in that simple lambda that you've defined for yourself and save it. This is really the only way that you should be using lambdas. You can't just put a lambda in the grid and expect to get something useful. You're just going to get a pound calc error. If you put it in here, then you'll later on be able to call it by its name. So in this case, you would be able to say, hey, equals my lambda, and pass it into your workbook. So once you've created that lambda, you're of course going to want to call it all over your workbook. It's really no different than any of our built-in functions, right? If you're familiar with, equals sum and passing it a few different things with commas in between it, you can do the exact same thing with the custom logic you defined through Lambda. And so all you do is you say whatever that name was, and then in the parentheses, you give it whatever the variables were that you defined as parameters in your initial definition. Now, there is one other way you can apply these that's really useful for testing, and you'll see that here at the bottom is, we can't store it in the cell, but you could write it in the cell and then immediately call it, and that way it will come back with a value. So in this case, down here at the bottom, you'll see equals lambda, number, comma, number plus 1, and then you'll see that parentheses with the 1 inside of it. That's basically saying, hey, I've defined this lambda here, and then I'm immediately going to supply it the number 1. And if you do that, it'll let you, try out a bunch of different test values. Once you've found something you really like, then you can select just the lambda and pop that into the name manager for reuse later. Now, getting just a teeny bit more advanced here, one of the things we realized people are going to need if they're defining their own functions is the ability to have optional parameters. Sometimes a variable will be there, and sometimes that variable will be something you don't have. In order to do that, we've made it so that when you're defining the lambda, you can just put an optional item in square brackets, and that will allow you to define the function in a way where it either does or doesn't have that, depending on what you need. So when you call it later, you can sometimes skip that parameter. We've also created a supporting function called isOmitted that you can use in the calculation portion to get a true false if that parameter is missing. That'll help you to create custom logic where you can perhaps return an error if something is missing, or you can use it to determine if you want to change your calculation. All right, so we've talked a bunch about Lambda, but really the most important thing is, how do you make this relevant to you and the work that you are doing? There's probably a ton of formulas you're using today that do exactly what you want. And they're not going to be the same as all these examples. If you have a second, quick pop open one of those workbooks and find one of those formulas that you have pasted all over the place and that is a real pain whenever someone asks you to update it. I'm sure there's something you're thinking of right now that meets that description. You're probably asking yourself, well, how do I take this existing formula and how do I turn that into a lambda, right? That's what you want to do, is you want to take away some of that repetitive work you're doing today. I'm going to use an example of an existing formula I have that's very simple. See it here at the bottom. It's equals 5/9 times cell B2 minus 32. You might recognize it as the formula for converting things from Fahrenheit to Celsius, and that's just the basis of how we're going to do this example here. All right, so let's take that formula and turn it into a function. So if we look at the formula, there's just a simple sort of set of steps that you'll take to convert that into a function. First thing we have to do is we have to find all the places where we're doing a cell reference. Doesn't matter if it's absolute or relative. If it's something that changes out when you're reusing the logic, you're going to want to write it down here as a cell reference. For step 2, think of a friendly name for each of those references. In this case, I think that, cell B2, that's really a temperature. So, I came up with that as my friendly name to describe it. And now for step 3, we're going to just put it all together and write it out. So first, of course, we have to start off with equals lambda. You can't make a lambda without the lambda function. And then after that, we're just going to add in our name here. So equals lambda temp. Now, the next thing's pretty easy. Just paste in your old formula as is. Don't worry about it. For step 4 here, you see we replaced the references. And so we're going to replace each reference with whatever the friendly name for it was. So I'm going to go look through it, read it, straight across. And here where I had B2, I just replaced that with the word temp. After that, I just have to close the parentheses, and that lambda is fully defined. It was super easy to go from a single-use formula I had to paste everywhere to now having a reusable function. Now, of course, if I want to reuse it, I'm going to have to toss it in the name manager and give it a name so that I will be able to remember what this is. The function's only useful if we're actually calling it, right? In this case, I put my function in the name manager. I named it to Celsius. It has that one variable that we defined earlier, temperature. And throughout the grid, I had that, really kind of long and yucky formula where it was at the 5/9. So anywhere I had that in my grid, I can now just replace that with equals to Celsius, and whichever cell I want it to reference. I can still do copy paste, I can still do autofill, I can treat it like any ordinary function. So now that we've explained how let and lambda work, hopefully you've seen the power that each of them have. There's one other important piece, is that you can combine these two to make even more powerful and amazing functions within your workbooks. So once you learn to combine them, you can now create really complex logic that's going to push the boundaries of what you can do in your workbooks. I have an example here, but rather than dive into this one in too much detail, I want to hand it back over to Chris, who's going to go through a whole bunch of cool demos and workbooks for you.
All right, thanks for talking to us about Lambda. Having said that, we're now going to switch over and go through some demos of let and lambda and try to put everything together. And then when we're done with that, I'm going to cover the next set of topics that are all about the new lambda functions that can supercharge your abilities that we released within the past month. So let's get started. All right, let's jump in. So the first thing I'm going to refresh your memory on is that example I gave where let can be used for debugging. So some of you might have already figured this out on your own. Don't spoil it for everyone else, but we're going to actually walk through the process of debugging. So just to get ourselves familiar with the example again, we're doing a sum of square roots. And the sum of square roots is getting a value from a square root we've previously calculated that's taking in an array. Now, as I mentioned, the trick that you're going to want to do when trying to debug formulas like this is just simply copying and pasting and changing the names. So instead of returning sum of square roots, I'm actually just going to return square roots. And what this does is it allows me to see the actual output that's coming out from square roots without having to use any other bit of UI. Now the issue that we're seeing here is pretty obvious. We're getting a pound value from the fourth value included in our range, which happens to be this one. So what I'm going to actually do is, since I know it's this fourth value, I'm going to inspect it because from my eyes, it looks like this is actually a blank cell. Now you might be looking, and the place you're going to actually want to look is up in the formula bar at the top, and you'll notice that we actually have a tick mark here. So somehow there was a tick mark that accidentally got included here, and so Excel thinks that it's actually a bit of text, and obviously there's no answer for the square root of a bit of text. So to fix this, you can simply just backspace that out, and you're going to see the formula actually get fixed. We're going to get the value 0. And just to prove, again, this is live, if I change this to something else, like let's say 4, you're going to get the value 2. Now, when you're done and you've debugged everything, the final thing you'll want to do is obviously fix your formula back up and recalculate that sum of square roots. So the final thing I'm going to return here is sum of square roots, hit enter, and just like magic, we're getting a result. Hopefully that shows a little bit of how to debug with let and some of the use cases we've found for it. We talked a lot, gave some quick examples of how you can author your own lambdas and everything, but the first thing I want to start with, just with the demo in Excel, is calling your own lambda function. So assuming somebody else, maybe one of your colleagues, has created these, I just want to illustrate how easy it is to work with these functions. It's just as simple as working with any other function. So in this case, I've decided to name this one count words. And what this formula is going to do is it's going to count the words in each string of text that I have here. This might be something you actually have found yourself looking online and found different solutions for, but suffice it to say it's actually a fairly complicated formula when you break it down. But once you've actually gone through the effort of creating that formula and then abstracted it into a lambda function, it's pretty easy to just reuse. So in this case, I'm just going to take all the values, close my parentheses, and you'll see that it's giving us the count as expected. And just to prove again that this is live, this is totally functional stuff. If I just add another entry and growing, and we can add yet another entry, you'll notice that we're still calculating the same results. And that's because lambdas can also support other different types of data. It natively supports all the data types that are found in the grid, and that includes arrays. So something to think about as you level up and you learn more about lambdas and create your own solutions. So while you might be at the point where you're able to call Lambda, maybe you've tried to author one yourself. And one of the first things that might happen that's a little bit confusing when you work with Lambda the first time is you can get errors. So in this case, we have a really simple Lambda. This Lambda just returns the value 1. That's all it does. Not terribly useful, but it's not important how useful this Lambda is. The pound calc is the thing we want to focus on. So what you'll notice is if I just enter that into the grid, or I took any of those examples that you might have seen from the slides and put it into the grid, you'll get a pound calc. Now it's a little bit more friendly of an error, and it tells you that this cell contains a lambda. You could go check the help documentation on it. But really what's happening here is you cannot return a lambda as a result to the cell. And you need to call this lambda or apply it. There's other terms that we use, but calling and applying are the common ones. And just like other functions that you might use in Excel, it's not terribly useful if you don't actually call that thing. This is also something that's important to remember as we continue on to the next topics, because lambdas are technically values. Just like we've added new data types into the ribbon through things like stocks and geography, we've added new data types of arrays, and we've also added a new data type that happens to be a lambda. This is a value that can be passed in through other functions, something that might be a little bit mind-blowing at first when you hear it, but pretty powerful when you figure out how to make use of it. So I've rambled on enough about that. If you want to actually fix this result, it's pretty simple. All you need to do is take that exact same function that you had before. And by the way, this is also how I would suggest authoring your own lambdas, is authoring them in the grid and then putting them into the name manager afterwards. The name manager isn't the greatest surface for authoring stuff, so definitely you'll want to try it out in the grid and then use this trick I'm about to show you where you can just call the lambda in line. Because remember, it's returning that function, and then all you need to do is call that function. So in this case, we can just open parenthesis, close parenthesis. This lambda doesn't even take any arguments, and we'll see the value of 1 being returned. The important thing about this is that you can use it for debugging, and you can use it for creating your own lambdas before you put them into the name manager later for storage. The other recent addition we've made that Michelle talked about was the added addition of optional parameters, which is pretty cool because just like first-class functions have optional parameters, lambdas have optional parameters now too, which is pretty useful. In this example I have here, just taking a look at the lambda, we've got 2 parameters. We've got one that's A, and I've stitched it up into this input 1 here, and then another one that's optional B. And again, you need to remember square brackets denote that this thing is optional. Then the calculation that I'm doing here is a rather simple one. We're just doing an if check. And with this if check, we're going to say, hey, is the value B omitted? Meaning, is the value B missing? Did that not get included? And if it is missing, we just want to say optional parameter missing. In this case, maybe you don't actually want to return some text that the optional parameter is missing, but this just shows you and illustrates a little bit of the control you have. But if you did include that optional parameter, we're actually going to add up the values of A and B. And again, I'm using that trick where we're calling stuff in line and not going to the name manager at this point, because this is something that I'm in the middle of authoring. So again, we're passing in one value, we're omitting the optional one, and so we're going to get the term optional parameter missing. But if we wanted to add those 2 values up, all I do is pass this in, and you'll notice that we get a result just as expected. And that takes me through this demo portion where we've talked a little bit about let and lambda. All right, so the next concept we're going to talk about is totally new stuff that we've released in the past month. And this is the ability to leverage the fact that lambdas are indeed new value types. Just like we've added other data types to the grid at this point of stocks, geography, the Wolfram entities, Power BI if you've hooked up those, and even the Power Query ones too. We've also added support for things like dynamic arrays, new errors, and if you're familiar with them, formatted number values. So the addition of all these new types allows us to explore opening new things, and in this case we've actually decided to call lambda a new type. This is a new value that can be returned, and again, if you remember, that's what's causing that pound calc error that you saw before. So again, just like we have support for strings, numbers, and everything else, lambdas are a new value type too. So what this means is that since it's a new value, it can do all the other things that values can do too, and that includes being passed between different functions. And so for this next section, we're going to talk a little bit about some new functions we've introduced, briefly touch on those, and then switch over to some demos because I think live demos are a bit better for illustrating some of the power contained within. First thing to cover is that we do have 6 new functions. And I'm going to walk through one of these because there's an important concept that I think you need to understand from all of this. And then we'll switch over to some live demos, as I said, to show them in action. So the 6 new functions we've introduced are map, reduce, scan, make array, ByRow, and bycall. Each have their own superpowers and their scenarios where you'll want to make use of them. Just a quick explanation on each of these. Map is one that you're going to want to use when you want to transform stuff. So if you have a value and you want to do a transformation to it and turn it into something else without affecting the original value, that's where map's good. Reduce is really good for reducing a whole bunch of values, maybe an array of them, down to a singular value by applying some repeated calculation. Scan's one that can take all of those same concepts from reduce, except it can calculate an array of those outputs. So in reduce, where you took an array of things and you reduced it down to a single value, with scan, you can actually take all those calculations that you did to reduce the value and return those as results to an array as well. Make array is probably pretty sensical in the way that we've named it, at least I hope so, and that what it allows you to do is create arrays. So before we had the sequence function and some other functions that allowed you to make arrays, but this really blows the lid off of those and allows you to make any sort of custom arrays that you might want. ByRow is pretty valuable because it allows you to take a lambda and apply it to each row. So if you have a table and you want to apply a single calculation and return a result for each row, that's where ByRow is useful. And then of course, the sibling function of byCall does the inverse of that. Instead of taking rows and returning a single result, this will take a column and return a result for each of those two. So hopefully that explains a little bit about what each of these do. But again, we'll go through some examples to show you a little bit of a live demo and how you might make use of it in your own scenarios. So the first thing to look at is the map function. This one's pretty interesting because the first set of arguments to map allow you to pass in a variable number of arrays or ranges. So for ease of illustration today, we're going to go through examples where we're returning one array. In the demo, I might show something with multiple arrays, but we'll get there soon. So with the map function, the first parameter is going to be that array, and the second or third parameter could be that, and the final thing that actually needs to be passed in is a lambda. Now this is important to understand because if you pass in one array, the lambda is going to take in one argument. If you pass in, let's say, 3 arrays, that lambda is going to want to be supplied 3 arguments. That all doesn't totally make sense. It hopefully will in the next couple of minutes as we walk through some examples. The other thing I forgot to mention was that map is great for doing value transformation. So in this case, what we're going to do is something that I view as a little bit easier to wrap your head around. Again, we're taking a single array, and then our lambda, which is what we're going to actually focus on in the center of the screen here, is really where all of the action is going to be happening. It's where Excel's doing all the heavy lifting, it's where those transformations are happening, and it's also where you're going to be writing whatever custom logic you have for the scenario that you're thinking about. So in this case, what we have is a lambda that just takes one parameter because we're passing in one array, and we've decided to call that value. And then the next section, the calculation of the lambda, is just going to check whether or not that value is even. Now, the other thing to make mention of before we start stepping through this is that we're supplying a range. In this case, the array or range that I've supplied is, you can see on the left side of the screen, that's 1, 2, 5, and 16. Excel is going to do a calculation for each of these. That's the thing that's a little bit mind-bending because obviously once you hit enter, Excel's super fast depending on how good your computer is, and it's just going to give you a calculation immediately without showing you all the steps it's taken to get there. So we'll walk through step by step and see how this works. So in this first one, what Excel does is it takes that first value from the range that we have, and that's 1. What it's going to do is it's going to take that value 1, it's going to pass it to the isEven function, and then it's going to return true or false whether or not that value is even. And this is something that's pretty simple when you go through step by step to understand. The second step that we're going to take is obviously taking the second value from that array, and that's going to be the value 2. So in this case, Excel will say, hey, is the value 2 even? It sure is. That answer is true. And then it's going to add the value true to the output array that you will eventually see when the calculation is done. Next thing Excel is going to do is obviously pull the next value. That happens to be 5. 5 is not an even value, so Excel returns false. And finally, with the last value, which is 16, Excel is going to check if that value is even, just like the other ones. 16 is indeed true, and so the final result we get is true. And with that, Excel returns the final result, which is an array. That's an important thing to remember with this one since it returns an array, and some of these other ones just return a single value or an array. And in this case, it's got an array of all of those results. For me, I find this pretty useful for a scenario where I might want to pass this into a filter function or do some further iteration within my calculations. But hopefully that gives a really quick example and overview of just how these new functions work and covers the fact that they are going to be taking lambdas and that lambdas are new values. So again, those are the things that you need to walk away with understanding today. All right, so that takes us through the map function, but there's still 5 other functions we need to check out today. I'm going to switch over to Excel in just a second, but before I do that, feel free to check out the link shown on the screen. If you're interested in learning more about these functions in general on your own time, check out aka.ms/Lambda Helper. That'll give you more examples and scenarios where you might find benefit from these functions and a great place to review all the concepts that we've talked about today. So without further ado, let's flip over to Excel and check out these new functions in action. All right, now that we're in Excel, let's get started. So the first thing I wanted to cover was how to use map with multiple array inputs. We looked at how to use map with a single array, but how does it work with multiple? So for the example we see in front of us, what we'd like to do is actually filter this data set down by a given criteria. And this is a great use case for map. We're actually going to filter based off of 3 conditions. So the first thing to do is call map. And as I mentioned, we're going to be passing in multiple arrays for this one. In this case, the first thing we're going to pass in is the size. Second thing is the color. And then finally, we're going to pass in the order date. We're passing these in because these are all related to the constraints that we're going to filter by. The next thing to do is call lambda. As I mentioned before, the lambda takes as many parameters as arrays that we've provided. So the first one we're going to pass in is going to be the size, the second one is the color, and then finally the date. And these are going to be the arrays that get passed into the lambda and calculated for every single instance. Now that we've got the parameters all figured out, it's time to write our calculation. So what we want to do is use the AND function. The AND function is useful because we can use that to check off a certain set of conditions. So in this case, we want to check if the size is equal to the given constraint, which is large. We want to check if the color is equal to a given constraint, which in this case is red. And then we also want to check if it was ordered after a specific date. So when the date is greater than this. And what this should do is return a set of true and false results to us that we can then pass into the filter function. So hitting enter, just as expected, we're getting a series of trues and falses, and it looks like there's actually only one result given our constraints. Now if we want to filter this out, all we have to do is wrap this in a filter call. So let me call filter. The array that we want to include is this table. And then the things that we want to filter, the conditions of true and false, well, we've already generated those using the map function. Then I can just close out my parentheses, hit enter, and we can see that indeed we did only have one order given the current constraints. And to prove just how flexible this is, if we were to change this, let's say we change it to medium, and then we wanted blue stuff, we're going to get even more results contained within our series here. So hopefully that shows you a little bit about how to use map and how you can use it for more than just one single array. The next function we want to cover is reduce. Now reduce is useful because it takes a series of values or a list and it reduces it down to a single one. So let's get started. In this case, we actually want to use reduce to count how many even values we have in our specific list. So I'll call reduce, and the first thing you're going to be asked for as far as arguments is the initial value. In our case, we actually want this to be 0. And this is an important concept to wrap your head around when using reduce. The way that reduce actually works is that it's doing a whole bunch of intermediate calculations using those lambdas. And those intermediate calculations are what we call the accumulator value, or a running total value, or you can also think of it as a tally if that makes sense to you. But all in all, it's going to do a whole bunch of series of calculations, and then the final one is going to determine what the output of our function is. So let's check this out through example. The next thing we need to see is the array, which is going to be the values that we have here, and then finally our lambda. Now this lambda takes in two parameters. The first thing it takes in is that tally that I mentioned that's going to be associated with that initial value. This is important because the lambda has no way of knowing what the previous lambda calculated without us passing something to it. And this is the way that you can make use of it within your own calculations. It's also important because if we don't find any even values, well, we want to return the result 0. And that would be the case if we set our initial value to 0 as we did. So now that we've added in the tally, the next thing is the actual array value. So let's pass in the array value. Now that the parameters are done, we need to write our if statement to check for our logic. So in our case, we actually want to check if the value is even, and that value that we're talking about is a value from the array. And if the value is even, we want to add 1 to our tally total. And if it isn't, well, then we just want to return the tally. Remember, if we don't find anything, it'll just return 0. So closing out the parentheses, this looks like a complete formula to me. I can hit enter, and you'll see that we're actually getting 14. Now this is awesome because this is something that you could have done before, but would have required a bunch of helper columns and a whole bunch of duplicate functions or formula calls. In our case, we've done it with one function call, and we're able to calculate this on the fly, even if we add more values to our list. The next use case that I like to talk about for reduce is actually creating what I like to call the aggregate if style functions. So you might be familiar today that we have a sum if function. We also have an average if function. There's also a max ifs function. But what we don't actually have is anything called product if, as you can see. Now this is a popular request that we have on user voice along with other aggregate if style functions. This is also a great use case for reduce because you can create these on your own, and I'm going to show you how. And just really quickly, the way that product if works is if a certain value meets a condition, it will multiply it with all the values that meet those conditions. So in our case, we want to look for values that are less than 10 and multiply all of them together. So let's get started. So we'll call reduce. Our initial value in this case, we actually want to be 1. And the reason for that is because if we multiply a value by 0, well, that's not good because then we're going to get zeros throughout the entire multiplication. Next thing we need is the array. So in this case, we'll pass in the values. And then the final thing is that actual lambda call. I'm going to use shorthand and call this A and B, A being the accumulator and B being the value from the array. Now, if we want to check and do this product if, we need to call the if function, and we need to do our check here. So we want to check if the value b is less than the constraint, in this case 10. And if it is, we want to multiply the accumulator times the value. And if it isn't, well, then we just want to return the accumulator. Don't do anything. Closing out these function calls, I can hit enter, and then we're going to see the value of 336 return. And I could store this in the name manager if I wanted and call it product if, and no one would be any of the wiser as to whether or not I wrote a Lambda that did this, or there was an actual function that was doing it under the hood. So hopefully that shows you a little bit about how you can unblock yourself making product if and illustrate some other aggregate if style functions you might be able to make yourself. The next function we're going to talk about is ByRow. If you recall, the way that ByRow works is by taking an array, and for every single row, it does a single calculation. In this case, we actually want to filter this array by using ByRow to see where the average temperature met a certain condition. In this case, we want to see where the average temperature for the week was greater than 85. Let's go ahead and call ByRow. Now, ByRow is a little bit easier of a signature than some of the other ones. It only takes in one array, and then the next thing we have to pass in is our lambda. And in this case, our lambda is only going to take one parameter, and that happens to be the row that we want to operate on. Now the next thing is our logic. So what did we want to do? Well, we wanted to calculate the average for the row, and we wanted to know if it was greater than 85. And so what this will do is it'll return a series of trues and falses that tell us whether or not the given week met that condition. So now that we have that, just like the prior example with map, we can pass it into the filter function. So I'll call filter. We want to filter the given array, which in this case is the entire table. And then what do we want to include? Well, we already have our trues and falses, so we don't have to worry about that. Close our parentheses, hit enter, and as expected, you'll see that there's 7 weeks that were greater than 85 degrees on average. So all in all, we had some sweltering hot weeks over here in Seattle, and that's what I was ultimately trying to calculate. The next function on our list is scan. Scan is very much like reduce, except instead of returning a single result, it returns the running total or that tally result or the accumulator result, whatever you want to call it, for every single calculation that was done. So let's figure this one out. What we want to do in this case is we actually want to create a running total of sales. This is something that you could do without these functions, but would require a lot of subsequent function calls. And if you added more data, you'd have to also duplicate those functions. Something that scan is much better at, and we can do with just one single function call here. Very similar signature, what's the initial value? In our case, we want our initial value to be 0 because we don't want to mess with our addition at all. Next thing is the array. In this case, we actually want our sales. And then the final thing is the lambda that's going to make use of this. And again, it takes an accumulator value. In this case, I'm going to call it running total. And then it takes a value from the array. And all that we need to do for this example is just add those two things together, because we're just taking a running total of every single value within the list that we've been given. And once I hit enter, you can see we've got our running total all through one formula. And if I were to add, let's say, August's data and add the value 200 here, you'll see that it continues to calculate those results for us. The last function that I have on my list to talk about today is makeArray. Now, hopefully the term of makeArray is self-explanatory, but if it isn't, what it does is it takes in 2 arguments, in this case rows and columns, and it uses that to create an array of those dimensions. And the way that the lambda works in this case is it also takes 2 parameters. It takes a row index, and it also takes a column index. Now these correspond with the amount of rows and columns that you want to generate. And you can make use of those optionally within a calculation. In our case, we actually want to create a multiplication table by using makeArray, and it's actually a pretty easy example to use because all you need to do to create a multiplication table given indices is multiply the 2 together. Just like that, I can close out my parentheses and you'll see we have a multiplication table, something you might remember from grade school. Now, while multiplication tables are probably not the most useful example for everyone here, there are examples where I tend to use makeArray a fair amount. One use case I find for them is whenever I need to do manipulations of arrays within lambdas. So in particular, you can do some tricky stuff using the sequence function, but it's a little bit tough. MakeArray is one of the functions we've introduced to get around some of those limitations to make things like appending arrays or doing transformations on arrays using the indices a little bit easier. The other thing that makeArray also happens to be good for is generating random sequences of data. In this case, we actually want to generate a random series of colors, and we're going to use makeArray to do that. So first thing is calling makeArray, and we actually want 10 rows in this case, and we're going to want 1 column. We don't want to generate multiple columns of these. Next thing is that lambda, and we're going to pass in the row and the column. Now for this one, we're actually not going to make use of those indices because I don't need them. I'm actually going to go ahead and call the choose function. Now what the choose function does is given a specific index number, it'll map that to another value. And so for our index number, we're actually going to want to roll some dice. So let's use the rand between function, which will give us a roll between 1 and 4 because we want 4 colors. The choose function has these value arguments, and what these are going to correspond to the values that get rolled by the random. So in the first case, if we roll the number 1, we're going to get red, and that's the color we'll return. If we roll 2, let's return blue. If we happen to roll 3, let's return the color orange. And if we happen to get the value 4, let's return magenta. And again, if I wanted to do 10 colors, I just have to pass the series of colors here and we can continue to generate. So closing out my parentheses and hitting enter, you'll see that we're able to generate a series of random colors. And if I were to go ahead and recalculate this, we can get new colors every time. If I wanted to say do something crazy like generate, I don't know, 10,000 of these colors, I can do that at the flip of a switch too. And the power is really at your fingertips for these ones. Now the last example I have today is one that I'm using to see what sort of crazy things you all can come up with. This is certainly not one that I use in an everyday business type environment, but this is a pretty cool and I think compelling example of stitching all these Lambda concepts together. And what this one we're going to do that I've already encoded, I don't have time to write it because it's a little bit more complex, but again, I'm using all of the things and tools that I've shown you today between make array, encapsulating lambdas, is we're going to set a chessboard. And this takes an optional parameter of true and false. And so I'm going to actually pass in the value true to this because what I want that thing to do is actually set the chessboard for us and put all the pieces here. Now I am giving a bit of a hint because I might be doing some matching to some tables that I've created ahead of time. But the other thing that this function is able to do is if I pass in the value false, it'll return all the coordinates on the board. Something that's just a little bit more fun and hopefully illustrates all the power at your fingertips just through the set of these Lambda functions. And I'm interested in seeing all the crazy, wacky, and useful things that everybody here today might end up building. That takes me through all the content that we had today. So again, on behalf of Michelle and the Excel team, I just want to say thank you to everyone for listening, and I hope you've learned something new.